Good afternoon, students. Am I audible? Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So in my last class, I think I had completed my discussion on the sedimentary rocks. So in this class, I'm going to continue my discussion on the metamorphic rocks and try to complete this one today. So what are metamorphic rocks? So in my rock cycle itself, I discussed and I had told you what is a metamorphic rock. Is it not? So those rocks which are modified by heat, pressure, and other chemical process, which are buried deep below the Earth's surface. Okay. So metamorphic rocks are the rocks which are modified by heat, pressure, and chemical processes, which are buried deep below the Earth's surface. So what happens is whenever the rocks are being exposed to these extreme conditions, they have been altered, and the mineralogy, the texture, and the chemical composition of the rocks will be changed. So this is one of the very important concept in the metamorphic rocks. So what happens is, due to these extreme pressure conditions, temperature conditions, when these rocks are submitted or subjected to that amount of pressure and temperature, what happens is usually their chemical composition will tend to change. The mineralogy of the rocks, the chemical composition of the rocks will be changed. Okay. So there are two important types of the metamorphic rocks. One is the foliated and other one is the non-foliated. Okay. So foliated metamorphic rocks are the ones which possess a layer-like arrangement. Okay. They possess a layer-like arrangement. That means the minerals will be arranged in the form of layers, one above the other. Okay. So what happens is, it may be having a layer-like arrangement as that of a mica. You can see the mica can be removed in the form of sheets. Similarly, these rocks will also be arranged in the form of layers, one above the other, or it will be found in the form of bands, alternate band of dark and light colors. Okay, one layer of a dark color and one layer of a light color minerals. Okay, so non-foliated metamorphic rocks are the ones which do not possess this layered or the banded appearance. So the non-foliated rock means they usually do not possess any of these properties like the layering arrangement or the banding arrangement or anything like that. They lack the banding or the layering arrangement. So those rocks are called as a non-foliated metamorphic rocks. Foliated metamorphic rocks means the ones that possess the banded or the layer like arrangement. Okay, so coming to the first important metamorphic rocks is gneiss. Okay, so gneiss is a foliated metamorphic rock which is identified by its banded layer. Okay, so here you can see how it is usually found. Here you can see banded layer, alternate layers of dark and light colored minerals. Is it not? You can see the light colored minerals form one layer, the dark colored minerals form one more layer, again light colored minerals, again dark colored minerals. Okay, so this type of arrangement is usually called as a gneissic arrangement. Okay, so it composed of the varying composition lenses or bands, and it contains the granular minerals with an interlocking texture. So other bands may contain the platy or the elongated minerals. Okay, with evidence of preferred orientation. Preferred orientation means it is the arrangement of the minerals in one trend. Okay, so it will be arranged in one layer, in one direction. Okay, all the minerals will be aligned in one direction. Such arrangement is called as a preferred orientation. Okay, so this is this banded appearance and texture that defines the gneisses rather than its composition. You don't worry about the composition. The composition may vary at any point, but this layering arrangement and the banding arrangement
Sir,
always
your screen
defines
is
the.
not visible.
Yes, come again.
Your screen is not visible, sir.
Now is it visible?
Yes, sir.
Okay, right. So you can see this, usually it is found in this way: alternate layers of dark and light colored minerals. Okay, so these alternate dark and light colored minerals are usually found in gneisses only, not in any other modes. Okay, only in gneisses you can find this alternate dark and light colored bands. Okay, so this dark and light colored bands, by virtue of which you can identify this as a gneiss without the chemical composition. Okay, gneiss may have a different chemical composition. Okay, that doesn't matter to the gneiss, but it is only the texture and this structure or the layer like arrangement of one mineral next to other mineral gives the characteristic feature of the gneisses. Okay, so the, you can see how does this form in nature. So gneisses usually forms by the regional metamorphic. Regional metamorphism at the convergent plate boundaries. I have already explained you what is a convergent plate boundary. Okay, whenever two plates collide against one another, they usually form a convergent plate boundaries. Okay, when the plates are of uniform composition, like the continental plate and the continental plate, or the oceanic plate or the oceanic plate. Okay, both of them have the similar composition. Okay, so this two plates, like your convergent plate boundaries or the divergent plate boundaries, when they collide against one another, when they hit against one another, when two continental plates hit against one another, they form a mountain. Okay, on the continent. Okay, I told you how Himalayas was formed in my earlier class itself. Okay, that's a very good example of the Himalayan formation. That is, Indian plate hit the China plate. Indian plate is a continental plate. China plate is also a continental plate. Both the continental plates collided against one another, and there was formation of the mountains of the Himalayas. Okay, similarly, if two oceanic plates collide or hit against one another under the oceans, then they result in the formation of the mountains under the seas. Okay, they form the mountains, though that are not called mountains, but they are called ridges in nature. They are called ridges. Okay, so whenever there are two continental plate conversions or the ocean plate convergence, okay, when two plates collide or converge against one another, then these gneisses are formed in nature. Okay, so it is a high grade metamorphic rock which is recrystallization under intense heat and pressures. So this alteration is also increased the size of the mineral grains, and that segregates them into bands. Okay, so what happens is, it's a high grade metamorphic mineral. Okay, where the grains recrystallizes only under intense pressure and heat. Okay, if you want that much amount of heat and pressure, you cannot expect that amount of heat and pressure on the surface of the earth. Okay, surface of the earth contains minimum heat of pressure and temperature, but excess heat and pressure and temperature, those are only found in the convergent plate boundaries, where two plates collide against one another, where lot amount of energy is being released, and that energy is utilized by this mineral to be formed, or this rock to be formed. Okay, so it forms in a very different ways also. So first path is the beginning of the shale, okay, which is sediment rock. Okay, so what happens is, small amount of metamorphism will change the shale into slate. Okay, shale is a sedimentary rock. Okay, so some amount of pressure and temperature at the contacts, what happens is, it converts into slate. Okay, the slate then converts into phyllite, and phyllite then into schist, and finally into a gneiss. So this is a order. Okay, this is always forward. Whenever the first mineral to form on the first rock to form in sedimentary process is the shale, after the shale, small amount of pressure and temperature changes them into the slate, then into phyllite, then into schist, and finally into gneisses. Okay, So this transformation, the clay particles in shale transform into micas and the other minerals, mica minerals, the shale itself. Okay, the clay particles that are present in the shale. Okay, there will be some kaolinite, there will be emectite, there may be some smectite. Okay, all these are the clay minerals. So these clay minerals, what happens is they transform into micas and they increase in their sizes. Okay, so the platinum finally what happens is they begin to recrystallize into granular minerals. So that granular minerals, when it forms, it is marked by the transition into gneisses. Okay, so coming to the composition, don't worry about the formation of the gneisses. Okay, so you have to know how it is formed in nature. Okay, what are the composition texture? So gneiss is not defined by composition, it is only defined by the bands of feldspar and quartz in an interlocking texture. Okay, so these bands are usually light in color and alternate with bands of darker colors, like one layer of the light colored mineral and another layer of the dark colored minerals or the platy minerals. Okay, so what happens is the dark minerals usually exhibit an orientation. It will be orientation determined by the pressures of the metamorphism. Coming to the uses, so uses is they do not split against the planes of weakness like other metamorphic minerals. Okay, there are usually some planes of weakness. Every rock possesses a plane of weakness, but this gneiss will not split along that plane of weakness. Okay, so what happens is this only the phenomenon is used by the contractors to use the gneiss as a crushed stone in railroad road constructions, in laying roads, building site preparation, and landscaping projects. You can say jelly kallu. If you have to be in very common language, layman language, it is called jelly kallu. Okay, you know, whenever they lay the road, before they lay the road, they use this gneiss itself as a crushed stone during your road constructions or road laying. So building sites, you know that during your foundations and in your RCCs, for your RCCs, they use this gneisses itself. So some of the gneisses also you accepts a very bright polish and is very attractive enough for an architectural stones. So beautiful floor styles are also being made, facing stones, stair threads, window sills, countertops, symmetry monuments, and also made from the polished gneisses. Okay, so you can see this is how a polished gneiss is used. Okay, it accepts a very beautiful polish. That's why it can be used as a polishing the artifacts also. Okay, and there is a legend that the ancient nomadic man used this gneisses to make arrows out of them. Okay, ancient nomadic man used this gneisses itself as it could accept a very beautiful polish. The sharper edges can be maintained for hunting the animals. He used this gneisses itself for the arrows. Okay, so next is a slate. I don't want to explain much about it because in your small days you might have written in the slates. Okay, you might have written in the slates. Okay, slates. And usually what they do is whenever they go to some preschools, they usually take the slates. Now I don't know whether you have done it or not, but usually children will be given that slate and the chalk piece. Okay, so it is a very fine grained rock, foliated metamorphic rock that is created by alteration of shale or mudstone. Okay, alteration of shale or mudstone by low grade metamorphism, very low grade. So it's not very high grade, very low grade. So I can say that metamorphism can occur from the temperature and pressure that is obtained on the earth surface itself. So usually on a hot sunny day you can see 40 to 50 degrees. That much is sufficient enough for the shale or mudstone to undergo alteration into slate. Okay, it's a popular for a wide variety of uses such as roofing, flooring, and also flagging because of its durability and attractive appearance. Yes, if you go towards northern Karnataka, most of the houses are being floored by this slate itself. Okay, many of the houses in the northern Karnataka are floored by this slate itself. Okay, because it's a very durable. Okay, coming to the composition, so slate is composed mainly of the clay minerals or micas. That will be dependent on the degree of metamorphism to which the mica mineral has been subjected. See, extreme amount of pressure and temperature will lead to high grade metamorphism. Okay, extreme amount of pressure and temperature will lead to form the high grade metamorphism. But here what happens is, usually slate is formed at a very low temperature, so that's why the mica minerals will be well preserved within the slates. The mica minerals will be well preserved within the mica sheets. Okay, so clay minerals in shale will alter to micas with increasing levels of heat and pressures. So slate can contain abundant amount of quartz, feldspars, calcite, pyrite, hematite, and also the other minerals. Okay, slate will always contain huge amount of quartz. Okay, the minor minerals are the feldspars, calcite, pyrite, hematite, and the other minerals. Coming to the color of the slate, so most of the slates are grain color and range in a continuum of shades from light to dark gray. Okay, slate also occurs in shades of green, red, black, purple, and brown. Okay, so the color of the slate is often determined or defined by the amount and type of iron and organic material that is present in the rock. So that type of the iron, I mean, if it is more of hematite, then it gives reddish color. If it is more of magnetite, it gives blackish color. If it is more of siderite, then it gives whitish gray color. If it is made up of more of limonite, it gives some of the yellow red color, not the red color, yellow red. Okay, rust color. You can see the rust is different from the iron color. Okay, so that defines the color of the slate. So how does it form slate? See, it is formed in a tectonic environment. For producing slate is usually a sedimentary basin. Okay, that usually involves in a convergent plate boundaries. Okay, shales and mudstones in that basin are compressed by horizontal forces. So once the compression starts, there will be minor heating also, because pressure and temperature are proportional to one another. Is it not? So pressure increases, temperature increases. If temperature increases, then the pressure also increases. If temperature decreases, pressure also decreases. Once the shales and the mudstones that I present are subjected to the compression, during that compression itself, this shales, the forces that is being released usually modify the clay minerals. Okay, modify the clay minerals, and then it gets converted into shale and the mudstone. Okay, so foliation, that is the development of the cleavages, will be at right angles to the compressive forces of the convergent plate boundary. This is very important. Okay, so the foliation, that is the layer like arrangement, takes place at the right angles to the force of the convergent plate boundary. If the plate boundaries are converging against one another vertically, then the forces will be developed on horizontal axis. If the horizontally, if the convergent plate boundaries are pushing the forces, then the foliation develops at the vertically, which usually is a cross planes. Okay, that cleavage itself, which is formed, is called as a slaty cleavage, wherein the parallel orientation of the plating minerals in the rock can be seen in a microscope. Okay, so what happens is, usually two micas are always perpendicular to one another, but in case of slate, two micas will be parallel to one another. Okay, so this parallel arrangement itself gives the rock the ability to break along smooth planes. Okay, it will not break roughly, but it will break down very smoothly. So people exploit this property of slate to produce thin sheets of slate, which are used in the construction process projects and the manufacturing also. Okay, so coming to the uses, so slate is used in the interior flooring, exterior paving, dimension stones, and also as a decorative aggregate. Small amounts or small pieces of slates are used to make the turkey calls. The turkey call means it is nothing but your rooftops, a type of rooftops. And also historically, slate was used for chalkboards, student writing slates. That is what I told you. In ancient days, people used to write them on the slate itself. Small children used to write on the slates. And also the cardboards which were used, or the chalkboards which were used, were made of this slate itself. Okay. And also billiard tables. Yes, billiard tables were also made up of the slate itself. Symmetry markers and also whetstones and the tabletops. Because it is a very good conduct electrical insulator, it was used for electric panels and switch boxes. If you go towards a house which is 100 to 150 years old, then you can see these things. In northern Karnataka, especially, as it's a very good electrical insulator, once it's a very good electrical insulator, what they used to do was they used to design them for the electric panels and also for the switch boxes. Okay. So these are the ones that are being beautifully made out of your slate itself. Because of its variety in color, you can see how the flooring has been done. Okay. They can use the alternate colors for the flooring purposes. Okay. So this is one wall that is built of the slate itself in the UK London Museum. One wall of the museum is entirely built from the slate itself. Okay. So this is a natural slate and this is a slate where people used to small children used to write them on their names and other things. Initially, when the children used to go to the schools, they used to carry the slate itself. They had to do all their homeworks and everything in this slate itself before the use advent of the books. Okay. Coming to the next important rock is a schist. So you can see how a cyst can be formed. See, you can see here cysts. These are the very beautiful cysts which contains the gemstones. Okay, this is one of the emerald that is present within the cyst, and these are the garnets. You can see the garnets which are found within the cyst. Okay, so these are the micas which are found within the cyst rock. Okay, so what is a cyst? It is a foliated metamorphic rock which are made up of plate-shaped mineral grains which are large enough to see with an unaided eye. You can see the micas. I have shown you how the micas can be seen without a anything at all. You can see through your naked eye itself. So it forms on a continental side of a convergent plate boundary where sediment rocks such as shales, mudstones, which have been subjected to compressive forces, heat, and the chemical activity. Okay, so this environment, metamorphic environment, is intense enough to convert the clay minerals of the sediment rocks into platy metamorphic minerals like the muscovite, the biotite, and the chlorites. Okay, so become a cyst. A shale must be metamorphosed in steps through slate and then through phyllite. I told you on my last slide itself how it gets converted. Shale then becomes a slate then becomes a phyllite, and phyllite then becomes a cyst. So cyst, if it further metamorphoses, then it will become a granular rock. Okay, so that granular rock is usually called as a gneiss. So gneiss will not undergo any further metamorphism. If it will undergo anataxis, that is melting. Okay, so coming to the schist, how does it form? It forms from a exposed to moderate level of heat and moderate level of pressure. So it is traced from the protoliths, that is sediment rocks from which it forms. It usually forms from the shales and the mudstones. How it forms? From the convergent plate boundaries again, because in convergent plate boundaries itself you can expect so much amount of heat and pressure. Okay, heat and chemical activity, they transform the clay minerals of the shales and mudstones into platy minerals such as muscovite, biotite, and the chlorite. So coming to the types of schists and their composition, you can say mica minerals such as chlorite, muscovite, and biotite are the characteristic minerals of the schists. These were formed through metamorphism of the clay minerals that are present in the protolith or the rock type. So other minerals which are included in this schist are includes the quartz, the feldspars, which are inherited from the main rock or the parent rock. So micas, feldspars, and the quartz are usually account for the most of the minerals present in the schist. So they are named after the minerals that are present within the schist. Okay. So to the visible minerals that are present within the metamorphic minerals, like if it contains muscovite, then it is called muscovite cyst. If it comprising of the biotite, then it is called as biotite cyst. If it comprises of chlorite, it is called as a chlorite cyst. Usually it is called as green stones. So what are the abundant minerals that are present in the cyst determines the name. If it is present of the garnets, it is called garnet cyst. If it is comprising of kyanite, it is called kyanite cyst. If it comprises of starlite, it is called as a starlite cyst. If it comprises of the hornblende, it comprises called as a hornblende cyst. And if it comprises of graphite, it is called as a graphite cyst. Based on the abundant mineral that is present, the name will be given to that mineral in that way itself. Okay, based on the abundance. Are schist used as a construction material? So it has got a many industrial applications. If it is abundant in mica minerals, low physical strength, and it is that's why not very suitable for the construction aggregate, building stone or the decorative stone. But it is used as a landfill site. Okay, sometimes it is used for a fills. Okay. Coming to the schist as a gemstone material, yes, it is a host rock for the many of the variety of gemstones. The gem quality of the garnet, kyanite, tanzanite, emerald, andalusite, speen, sapphires, ruby, scapolite, iolite, chrysoberyl, and also many other gem materials are found in the cyst itself. Okay, you can see here beautiful garnets which are present within the cyst, the emerald which is usually found in the cyst itself. Okay, so I'll stop my discussion here. If you have got any questions, we can ask. You can ask me now. Drop in your attendance. We shall continue discussion next class. Thank you very much.